Okay, we're going to go over this review. So I know that this negative in the front will be a reflection. It'll reflect over the x-axis. And this plus 4 right here with the x will go left 4. So normally it looks like this, but it'll reflect across the x-axis and it'll move to the left. So it'll look something like this in the end. However, let's get those exact points. So I'm going to come over here. This went left 4, so I'm going to center my graph around negative 4, and I'll plug in numbers around it. So let's plug in a negative 5. So what I can do is, my equation is negative 3 to the x plus 4. So we're going to plug in a negative 5. So negative 5 plus 4 is negative 1. Whenever you have a negative exponent, you need to flip the base. You do the reciprocal. So now it looks like this with the positive 1 and you flip the base. You still have a negative here. So this is just negative 1/3. So that means for a negative 5, we got negative 1/3. And if I can graph it over here, 1, 2, 3, 4, negative 5, negative 1/3 is about there. Okay, now we're going to plug in a negative 4. So negative 3 to the negative 4 plus 4. Negative 4 plus 4 is 0. Anything to the 0 power is 1, and you still have that negative there. So this is negative 1. And I'll plot that point. Negative 4, negative 1 is here. Next, I'll plug in negative 3. So I have 3, negative 3 to the power of negative 3 plus 4. Negative 3 plus 4 is 1. 3 to the power of 1 is just 3, but you still have that negative there. Let me do that one more time. It's in the frame. So 3, and I'm plugging in a negative 3. Okay, so this is my function. I plugged in a negative 3. Negative 3 plus 4 is 1. 3 to the power of 1 is 3, and you still have that negative there. So that's just negative 3. So I'll add that to my table. Okay, so let's go ahead and graph those points. Negative 3 is right here. So this is my graph. And this is an exponential function, so I have a horizontal asymptote right here at y equals 0. So that's my asymptote at y equals 0. My domain is, it goes forever this way, so that's negative infinity, and it'll go forever to the right. Your range, the bottom is pointing downward to negative infinity. The very top is at the asymptote 0. Your end behavior, as your graph, as the x values go to the right, your graph is going down. F of x is going down to negative infinity. As your graph goes to the left, so as your x values go to the negative side, as you go to the negative side, it's just getting closer and closer to the asymptote. So that's 0. And this graph is always decreasing. See, if you start on the left and follow the graph, you're always going down. So it is decreasing forever. So I'm going to put negative infinity to infinity. It is decreasing. Okay, let's try a log. Okay, so I already did that one during class. So let's do this one. Log x plus 3 minus 4. Okay, so this went to the left 3. So left 3 and down 4. And for a log, remember the parent function looks like this. There's an asymptote right here at x equals 0 that it gets close to but doesn't touch, and then it increases this way. But however, it went left 3 and down 4. So it went left 3, so 1, 2, 3, your asymptote's now here. So 1, 2, negative 3, 1, 2, negative 3, my asymptote is right along here. Okay, so let's graph some points. Your parent function, let's just graph log of x. And remember, there is no base written, so I know that my base is 10. So the table that you always do is 1, 0, your base 1. So 1, 0 is right here, and 10, 0 is way off the page. Let's condense this a little bit. Let's make this -1, -2, -3. And make this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so 10, 1 is right here, and 1, 0 is right here. Okay, so normally this is my parent function. However, each point went left 3 and down 4. So this point right here went left 3, 1, 2, 3, down 4. 1, 2, I'll make it like this, 2, 3, 4. So this point went left 3, down 4. This point is also going to go left 3, so 10, 9, 8, 7, down 4. 1, 2, 3, 4. So right here. All right, so that's my new graph. Let's answer some questions about it. So the domain of my new graph, it starts at -3, and it goes to the right, infinity. I'll write that a little better. Your range, the very bottom, is at -infinity, and then it goes up infinity. Your asymptote is scooted over to the left at 3, so it's at x equals -3. Your end behavior, so as you go to the right, so as your x values increase to the right, as it goes this way, your graph is going up to infinity. And it never goes past this asymptote, so it never goes to the left side, so that one doesn't exist. And your graph is always increasing, and it's the same as the domain in this case. So it is increasing, starting way over here at -3, and it just keeps going up. So that's -3 to infinity, where it's increasing. Okay, so let's evaluate some logs. So this is asking 3 to what power gives you 27? I know 3 times 3 times 3 is 27. Whenever these match, those cancel out, your answer is 5. So if you're curious, the reason why is they're using the power property. Remember, where the exponent can come to the front. So this is 5 log, 5 times log base 3 of 3. And 3 to the power of 1 will give you 3. That's just 1. 5 times 1 is just 5. Easy way, it just cancels out when those numbers match. E and natural log, they cancel out. It's just 4. Here we're going to use the product property. So this is log base 6. 54 times 4 is 216. And I know 6 to the power of 3 is 216. So the answer here is 3. All right. Here, this is being divided. I'm going to use the quotient property. So this will be log base 7 of 7 minus log base 7 of 3 to the power of x. Whatever's in the numerator goes here. What's in the denominator goes here. This is just 1. Remember, a cubed root can be written as log base 7 of x to the 1/3. And using the power property, this can come to the front. So this is your answer. Okay, let's do a condensing. So this 6 can come up here so that it's log 2x to the power of 6 minus log x plus 7. This exponent can come to the top. That's the power property. And this is subtraction, so you can use the quotient property. So this will be log. You might write a single log. The numerator goes in the top. The denominator goes in the bottom. Okay, let's try this one. This can go up here, so this is natural log of x to the 5th power plus natural log y. So now, just use the product property. You multiply these together. So this is x to the 5th times y. That's your answer. Okay, let's just do do a few of these. This one is neither, okay? We never have a negative base. So you just write neither and keep it moving. Here, this is a growth because this base is bigger than 1. So I'm going to use this formula. So the base is 1.37. So this is your base. It's equal to 1.37. So we're going to solve for R. So that means R is 37.37. If you change it to a percent, you'll get 37%. And this is growth. Your initial value is 2. That's your initial value. Here, your initial value is 2. That's your initial value. 3 is your base. That's bigger than 1, so this is a growth problem. So I'm going to use the same part. 1 plus R equals 3. If you solve, you get R is 2. Change it to a percent. That's 200%. The decimal is right here. You move it over twice. Okay, here, your initial value, you don't have anything right here, so you can imagine a 1. So your initial value is 1. This is your base. That's less than 1, so this is a decay problem. You're going to use this formula. Okay, so this is your base, 1 minus R, but they're saying your base is 0.5. So subtract 1, you get negative R equals negative 0.5, divide by negative, you get your rate is 0.5. Change it to a percent, you get a 50% decay. You have to express it as a percentage. Okay. Word problems, we did several of these yesterday, so that should be fresh on your memory. I just wanted to go over these because it's been a few days since we worked on these type of problems. I guess I can do this one real quick. Okay, so these are all being multiplied. This is 12 times x to the 5 times y to the 9. So I'm going to use the product property. Look back at your notes or watch that video. This is log 12 plus log x to the 5th plus log y to the 9th. I'm using the product property. Now these exponents can come to the front. So this is log 12 plus 5 log x plus 9 log y. Okay, so we expanded it. All right. Okay, so that's a good review of what we went over these past several days.